Hello everyone, in this video we'll be solving problem 108, convert sorted array to a binary search tree. The problem statement is, given an integer array nums where the elements are sorted in ascending order, we need to convert it into a height balanced binary search tree. Height balanced means that the total number of depth on each side of a node should be equal or the difference cannot be more than 1. Let's look at example number 1. With this nums array, its equivalent representation of a binary search tree is in this form where it is height balanced. If you look at the number of elements on both left and right side of a node, it's either equal or the difference is less than or equal to 1. If you look at this node, -3, it has one node on its left, but there is no node on the right. So difference is 1. Similarly for node 9, there is one node on the left, but no node on the right. And if you look at node 0 and the total depth on both left and the right side have the depth of 2. If we consider this as 1 and the other one being 2, similarly here we have 1 and 2. So the total depth on left and right is 2 and 2, which are equal. So it is height balanced. I hope you were able to understand the problem statement. Now let's switch to whiteboard and discuss how we can build a binary search tree which is height balanced using the array. We need to make sure that the total number of elements on the left hand side of the node are almost equal to the ones on the right. It may not be exactly the same because we could have a difference of up to 1 in the depth, but we need to try and make sure at least the number of elements are close to each other. And the simplest way to do it is to identify the middle of the array, make that as a parent node, and all of the elements to the left or before that node or before that index becomes part of the left leg. All of the elements after it in the array becomes part of the right leg. So we need to calculate the mid of the array. So in this array, 0 is the mid. So we'll create a node with value 0. We'll take the same approach to calculate everything for all the elements for its left leg and all the elements to its right. So because we use the mid of the entire array to calculate the root node value, for the left node, we'll do the same. We need this node here. We need to calculate the value for this node, and the total values that are available to us are -10 and 3. Just like we did for 0, we calculated the mid and then took the value. For between these two values, the mid would be 3. So we'll save 3 here and split the remaining items. Because there is only one item left before 3, which should be to its left, we'll create a left leg for 3 and save -10 over there. And there are no elements after 3 in the remaining array, so there will be no right leg for 3. Now let's calculate the right leg for node 0. We'll take the same approach. We'll calculate the mid. So between the two numbers, the mid will be 9. So we'll save 9 here as the right node to node 0 and see what our elements are remaining to build the left and the right leg for node 9. So we are left with only 5 on the left side or before 9. That will become the left leg of node 9, and there are no values after 9. So there will be no right leg. With this approach, we were able to construct the binary search tree with O of n time complexity, as we were iterating through the entire array only once, and the space complexity is O of 1. As we are not creating any new variable to maintain, we are just building this binary search tree on the fly while we are moving the pointers from mid and calculating the left and the right leg respectively. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. In the main method, I first check if my input is not null and the length is greater than 0. If either of the conditions are not met, then I am returning null. Then I am calling this helper method build tree and passing the nums array given as the input. I being the starting point of the array and j being the last point. When we are beginning the iteration, my I will be 0 and j will be the last element in the array and its corresponding index. So if we use the example that we just discussed, it will be 4 as there were total 5 elements. If j is less than I, then we return null, which means we have already calculated all of the elements and j being the last element or the right hand side should not be less than I. So we return null. We then calculate the mid and then identify its corresponding value and create a new node. Then assign the new node's left leg by calling the build tree again, but this time we are passing the I as is, so the left index stays the same, but the right index shifts. So it will be mid minus 1. Then for the right leg of the node, we are calling the build tree method again, but this time we are incrementing the I to mid plus 1. So we are calculating the right side or getting the right band while j stays the same. After the recursive loop is complete, we'll have the tree node ready to be returned. This code, when submitted on LeetCode, beats 100% of the submissions made so far in terms of time complexity, and in terms of memory consumption or memory utilization, it beats 23% of the total submissions. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the source code is available in the description below. Feel free to check that out. If you have any questions, feel free to reach out to me. Happy to talk about it, and I will see you in the next one. Thank you.